Today we will determine the slope of the graph of a given trigonometric equation at several of its points. So the specific equation is sine of x plus cosine y equals to 1. And because the sine and cosine are periodic functions, then so is the graph of this equation. And in fact, its graph consists of an infinite number of identical closed curves that are repeated every 2 pi units in both the x and the y directions. So here we have plotted the graph of this equation between 0 and pi with respect to x, and from negative pi over 2 to positive pi over 2 with respect to y. So to find the slope of the curve at any of its points, we must first compute dy dx. So to do this, we will differentiate the equation implicitly. Okay, so that is going to involve setting the derivative of the left side of the equation with respect to x equal to the derivative with respect to x of the right side of the equation. Now the left side is a derivative of a sum, and so by our sum rule, we know that that's equal to the sum of the derivatives of the sine of x with respect to x plus the derivative of the cosine of y with respect to x. Because 1 is a constant, its derivative, of course, must be 0. So now we had previously shown that the derivative of the sine of x with respect to x is the cosine of x. To differentiate the cosine of y with respect to x, we have to use the chain rule. So we begin by differentiating the cosine of y with respect to y, which yields minus the sine of y, and then we multiply that by the derivative of y with respect to x to get the x derivative of the cosine of y. So now this difference must equal to 0. So to solve for dy dx now, we'll first subtract the cosine of x from both sides, so we find minus the sine of y dy dx is equal to minus the cosine of x. And now divide both sides by the sine of y to conclude that dy dx is the cosine of x divided by the sine of y. Okay, so that's our derivative formula, okay, given in terms of the x and y coordinates of the points along the curve. So specifically, we would like to compute the slope of the curve at these 4 points. So our first point is P, which has coordinate pi over 6 for x, pi over 3 for y. So at the point P, the slope will be the value of dy dx, right, when x is pi over 6 and y is pi over 3. So that will be the cosine of pi over 6 divided by the sine of pi over 3, which is the ratio of radical 3 over 2 divided by radical 3 over 2. So of course that yields positive 1. So the slope of the tangent line at P is plus 1. At the point Q, the slope will be the value of dy dx at the point having x coordinate 5 pi over 6 and y coordinate pi over 3. So that will be the ratio of the cosine of 5 pi over 6 divided by the sine of pi over 3. So remember that in the second quadrant, the cosine is negative. So the ratio becomes negative radical 3 over 2 divided by positive radical 3 over 2. So the slope is equal to minus 1. the tangent line at point Q is of slope -1. At the point R, the slope will be again the value of the derivative at the point having an x-coordinate of 5 pi over 6 and a y-coordinate of minus pi over 3. So we get the ratio, the cos 5 pi over 6 divided by the sine of minus pi over 3. Okay, and so again, the cosine is negative radical 3 over 2, and the sine at minus pi over 3 is also negative radical 3 over 2, so the slope at point R is positive 1. That this line has a slope of positive 1. And then finally, at the point S, the slope dy dx, right, will be given by the cosine of x, the cosine of pi over 6, divided by the sine of y, the sine of minus pi over 3. So the cos of pi over 6 divided by the sine of minus pi over 3 will be positive radical 3 over 2 divided by negative radical 3 over 2, or minus 1. So the slope at S is minus 1. So we see that the lines, the tangent lines at S and Q are parallel, as both have slope minus 1. The tangent lines at P and R are also parallel. They both have slope positive 1. Of course, because 1 and minus 1 are negative reciprocals of one another, we also know that these lines, these tangent lines, are intersecting always at right angles. So we were able to do this analysis of the slope of the tangent lines at these various points along the curve. But before we conclude, let's make one further observation, namely that the slope of the graph of this curve will be 0 at the points where x is equal to pi over 2, because the cosine of pi over 2 is 0, okay, which is going to make the derivative dy dx equal to 0 at the point pi over 2, and at the point pi over 2 minus pi over 2. So we could write that down, that the slope of the graph is 0 at the points where x is pi over 2, since the cosine at pi over 2 is equal to 0. So that is at the points pi over 2 comma pi over 2 and pi over 2 minus pi over 2, the slope is 0, and the graph has horizontal tangent lines at these two extreme points, as the horizontal tangent lines. And so I hope you found this implicit differentiation example to be clear and instructive. Thanks for watching.